So if you'll observe, what is the meaning of to make the equation more informative means we can able to come to know the each and everything about the chemical equation if we'll make the equation more informative. So now, what are the methods to make this equation more informative means we are having three methods. One is by indicating the physical state of the reactants and products. So that is the first one. So as we know that, what is the meaning of equation more informative? It will give the more information about the chemical reaction. It will give the more information about the chemical reaction. That is only known as, understand, more informative or information giving equation. Information giving more informative or information giving reaction. Information giving reaction. So now, if we'll observe this information giving reaction, the chemical equation can be made more informative in only three ways. Understand? So we can make this equation more informative by in the way of three methods. In that, the first one is by indicating the physical state. Remember, by indicating the, now you don't write, I will say, by indicating the physical states of reactants and as well as products. Reactants and products. So if we take any chemical reaction, who is present? Is there any other thing present except reactants and products? Is it any other thing is present? Is it any other thing is present in the reaction except reactants and products? No. So in reaction, if we take only reactants and products is present. Next one. This is the first method to make the equation more informative. And the second one is by indicating the heat changes. Understand? Heat changes means in the sense of either it is absorbing heat or it is releasing heat. So that is only called as heat changes. So by indicating the heat changes, taking place in the reaction, so that is taking place in the reaction is the second way of making the equation more informative. Like that, the third method is, understand, by indicating the conditions under which the reaction taking place. Means in the sense of what is the catalyst we are using, either we have to increase the pressure, we have to decrease the pressure, that is called as conditions. Understand? So when it will take place, like that, it will make it, it will mention the conditions. Understand? So regarding about the equation, that is also will make us the equation more informative. So that is the thing. So applying the conditions, mentioning the conditions, understanding, under which the reaction will take place. Under which the reaction takes place. So this is all about the ways of making the equation more informative or information giving equation. So now here,
sir, can you please say the third one again, sir?
What, Amma? I will explain.
Third one alone, can you?
I will explain. You just listen. Now,
okay.
If you will observe here, first one, physical states of reactant and product. Let us come to here. Let us explain this one first. So, as we know that there can be 4 physical states for the reactants and products of chemical reaction. One is in this chemical. Remember, always in chemistry, any kind of reaction if we take, always how many states will be present? Reactants and products. How many states will be present? Always matter will be present in how many states? As we know that 3 states. One is solid, liquid and gases. Is it correct or not? Solid, liquid and gas. Is it true or not?
Yes, sir.
Yes. Along with that here, you remember, understanding, in chemical reactions, all the reactants and products may present in one more state. That is only called as aqueous state. So if we take the first one, physical states of reactants and products, understand? So there can be 4 physical states for the reactants and products of a chemical reaction. In that, the first one is, what is the first one? solid, and the second one is liquid. I will explain you with the example also. Liquid, and the next one is aqueous solution. AQUEOUS. Aqueous solution means any substance dissolved in water. Understand? Any substance dissolved in water, then that solution is known as aqueous solution. Is it okay, ma? Understood? And also last one is gas. So these are the four physical states of reactants, understanding, and products. Is there any doubt, anyone? Don't make sound. Clear?
Yes, sir.
Now, if you'll observe here, symbols is most important. Always remember, solid is represented with a S, liquids is represented with a L, understanding? And aqueous solution is represented with a AQ. Whenever you will see a bracket below the substance AQ, it is indicating aqueous solution, and the gas we can represent with a Z. Understand? So these are the symbols of states of the reactants and products. Understood? So now I will explain with the example. Shall I say the example? Somebody is making noise, please avoid it. Okay. So now let us discuss with the example, then we people can understand more even clearly. So as we know the example, the first example, zinc and hydrogen sulfuric acid. Tell me what is the zinc and sulfuric acid? Reaction. Reaction, tell me. You are studying from first, correct? Zinc reacting with sulfuric acid, what will form? Example for first one. Zinc reacting with sulfuric acid. What is this? How many times I should say? Zinc is reacting with sulfuric acid, H2SO4. Understanding? Which will give you ZnSO4, zinc sulfate plus hydrogen gas. So now, let us represent this equation more informative. Understand? So as we know that zinc is present in solid state, so ZnS we can write. And H2SO4, it is what? What is the state of H2SO4, please? What is the state of H2SO4?
Liquid, sir.
Liquid state illa. It is dissolved in water. Acid is dissolved in water. Then what is the state? Aqueous state. Understand? Aqueous state. As well as zinc sulfate. What is the state? Anybody? What is the state of zinc? It is also looks like a liquid. So it is also which state? Aqueous state. And hydrogen gas. Gas means what we can do? Pranita, gas means what is the symbol? G. G. That is. So if you'll observe this equation is more informative because it will tells us the physical state of various substances involved in it. Understand? And it will tells us that zinc is in solid state, H2SO4, sulfuric acid in the form of aqueous solution, and this is about reactants. Products, if you'll observe, zinc sulfate is also in aqueous solution, but hydrogen is in the form of what? Gaseous state. Gaseous state. So now, one question you people need to ask immediately if you are studying about this and all, how to make it more informative and all. Immediately your brain should ask, why we should learn this? Is it true or not? Yes or no?
Yes, sir.
Yes. So that question should come in brain. So why we should learn this one means, suppose you remember, few substances when they are in solid state, they won't show the reactivity. Is it true or not? Few substances, if we take in solid state, they won't show the reactants. For example, if we take pure acid if we take only H2SO4 if we take, then there is no reaction will take place. No reaction will take place. When it is in aqueous state only, the reaction will take place. As well as you see, products we are getting hydrogen gas. If you don't know that, hydrogen gas is producing that. Understand? Then you cannot use any kind of technique to store that hydrogen. Correct or not? So whatever the gas is released, it will escape into atmosphere. Is it yes or no?
Yes, sir.
Yes. So that is the importance of thing. So how we can store the reactants as well as how we can collect the products and all, which we can come to know with the help of this one. Understand? So that is the main importance of making the equation more informative. Understand? And few times, few reactions, if you remember, insoluble solid substance will form at the bottom of the container after the reaction. After the reaction. While we are studying the types of reaction, you people will study that. Understand? So if any kind of reaction, after the reaction, some insoluble substance is forming at the bottom of the test tube or container, then that insoluble product is only called as precipitate. What was to call? Precipitate. Understanding? So I will say that reaction. We are having one type of reaction called as precipitation reaction. So by the time you will study. So in some case, an insoluble product is formed by the reaction between, understanding, solutions of reactants. Solutions of reactants are solution and a gas. So there, an insoluble solid substance is only called as precipitate. What we used to call?
Precipitate.
Precipitate. So this precipitate is a solid substance. So its physical state is indicated in the equation by symbol S, or else we can write the precipitation, formation of precipitation, we can write PPT. This is the representation of formation of precipitation reaction. Are you people understanding? Yes or no? I will explain you with the example now. Is it
Yes,
okay
sir.
now?
Yes, sir.
Ashika, Pranita,
Yes, sir.
Anusri, now you see. So what I am saying, this precipitation will form, only remember, not with the solid reactants and not with the liquid reactants and something. Understand? Always this precipitation will react, understanding, only when the reactants are both the solutions of reactants, means in the sense of they must be aqueous solutions. Understand? Both the reactants should be, two reactants should be present, both the reactants, understand, must be, second reactant must be aqueous state, or one reactant must be aqueous state and another reactant must be gas. So in this case only precipitation reaction will form. When the precipitation reaction will form, they will ask. Are you people understand? So when the precipitation reaction will form, when the given reactants must be solutions of, understanding, substances, means in the sense of both the reactants is in aqueous solution, or one is in aqueous solution and another one is gas, then in that after the reaction some insoluble solid substance will form, that is only known as precipitate. Understanding? So this precipitate we can represent in the chemical equation by using yes, solid, or by using PPT. So most of the cases will represent with the PPT only. Are you people understand? Yes or no?
Yes, sir.
Yes. Now
Yes,
you
sir.
observe calcium, and let us see the example for this one. So now if you observe this example, calcium hydroxide. What is the formula of calcium hydroxide? Let me, anybody? Calcium hydroxide. Calcium hydroxide. Calcium hydroxide. CaOH2 twice. Understand? This is only called as calcium hydroxide. CaOH twice. Note it down. Calcium hydroxide. Calcium hydroxide. This is only called as lime water. All of you remember, lime water is also known as calcium hydroxide. Understand? When it is reacting with carbon dioxide gas, actually it is the state, it is aqueous state, AQ, aqueous state, reacting with a gas. So in this case, precipitation will form or not? Observe very carefully. One is aqueous state and another one is gas. Is it reaction will take place or not?
Yes, sir.
Yes, because it is a condition for formation of aqueous state. PPT. So now products will come like calcium carbonate, CaCO3, calcium carbonate, CaCO3, calcium carbonate. It is what? It is a PPT. PPT means what? What I said, PPT dot. PPT dot is indicating what?
Precipitate.
Precipitation. Precipitate plus we used to get water. Water is what is the state of water? You should tell me. What is the state of water?
Liquid.
Liquid. Very good. And you remember this precipitation color will be white color, white PPT. Then you people can understand more easily. So this is solid. Here you represent solid, and this is white PPT. So what is the calcium carbonate PPT color?
White.
White PPT. Very good. Note it down.
Every time the precipitate will be in white color or different, sir.
In this reaction, in this calcium carbonate alone, it's white color. Different substances, different colors will come. Is it okay?
Okay. Okay.
Yeah. Till here you note it down. Whatever you want. So this is the first one. So what is the first? What is the first way to make the equation more informative? By representing their physical state. Understand? So how many physical states we have? How many physical states we have?
4, sir.
4 physical states: solids, liquids, aqueous solutions, and gaseous state. That's all. There is no another state of matter. But you remember, aqueous solutions means substance dissolved in water is called as, means solution with the water, then that is called as aqueous solution. So if you want to form the precipitation reaction, so the reactants, what is the state of reactants? Anusri, if you want to form the precipitation reaction, what is the state of reactants?
Both the reactants should
Both
be
the
aqueous
reactants
or
must be either in aqueous state or must be, one is in aqueous state, another must be in gaseous state. Is it okay?
yes, sir.
Yes. So now examples I have taught. You finish it. That's all. Can I erase it?
Yes, sir.
What is the second method? This is the first method. What is the second method? Tell me. Akshaya. What is the second method? What is the second way to make the equation more informative? What I said? Anusri? Ganapati?
Heat, sir.
Ganapati, you can communicate freely, no issues. What is the second method? Heat changes. Very good. Akshay is changing, heat changes. Nice. Now the second method is to indicate the heat changes in a equation. Write it. Second method is what? To indicate heat changes. To indicate heat changes in a equation. Heat changes in a equation. That's all. So now, if you'll observe this one, heat changes in a equation. So what is the two things will take place? You tell me. So in this under, always reactions are two types. One is either heat will absorb or else heat will release. That's all. Is it correct or not, Amma?
Yes, sir.
Few reactions will absorb the heat energy. Few reactions will release the excess heat energy. So there is no other way of thing. Either heat will decreases or heat may be increases. That's all. So to indicate these heat changes in equation, we can come to know either the equation in this given reaction, heat is releasing or heat is absorbing. So let us go with this here. There are two types of reactions on the basis of changes involved. Which change, Amma? Heat changes involved. One is exothermic reaction in this. First one is exothermic reaction. I will say later we will study what is the types of that. So one is exothermic reactions and the next one is called as B, endothermic reaction. Endothermic reactions. So now what is exothermic? What is endothermic? I will say. So to indicate heat changes in a equation, we are always having two types of reactions on the basis of heat change involved. One is exothermic, next one is endothermic. So let us go with the first one now. What is the first one? Exothermic reaction. So what is the meaning of exothermic reaction means? Those reactions, yes, those reactions in which heat is evolved, means heat is produced after the reaction. Heat is released during the reaction is only known as exothermic reaction. So the reactions in which heat is evolved, are known as exothermic reaction. Note it down. Exothermic Shortcut I'm writing reaction, but you people write full form. R into N is reaction. So for example, let us go with the now example. Let us go with the example. If you observe carbon, how many of you know carbon? Any kind of coal or wood or something, paper, everything contains carbon only. What is the state of carbon, Amma? What is the state of carbon?
Solid.
Solid, very good. So if you take carbon, if you start burning, it will react with what? It will start heating. Burning means which one? Burning. Oxygen. So oxygen from where? From air. Air from atmosphere. So it will start reacting with oxygen and it will form. What is the gas it will form? Guess it. Carbon and oxygen. Carbon and oxygen. Carbon dioxide. What we used to call? Carbon dioxide. Understand? Carbon dioxide. Along with that, plus heat. So plus heat indicate what? Heat is releasing or heat is absorbing? Heat is releasing or heat is absorbing? Plus heat means heat is always releasing. Understand? That is you have to remember. So here if you'll observe in this reaction, the burning of carbon in oxygen, understanding, is an example of exothermic reaction because heat is evolved in this reaction. So remember, always exothermic reaction is indicated by writing plus heat. Note it down. By indicating exothermic reaction, by indicating writing plus heat, or we can write, understanding, plus heat energy is only known as exothermic reaction. We can write either plus heat or plus heat energy, or just we can write as a, or you can write just as a energy also. It is also correct. Just if you write energy, it is also correct. So, but where we should write? On reactant side or product side? You tell me. Reactant side or product side? That is what? If it is releasing, then we can write in the product side. So this is the first type of change in temperature. Understanding? Indicating heat changes. Sorry, not temperature. Heat changes. That is exothermic reaction. Note it down, all of you. This is for what? Example of exothermic reaction. One more also we can write, like methane. Our cylinders contains methane, ethane and all. So methane is a, what is the state of methane? What is the state of methane? Methane is a what? Second example. Methane is a what?
Gaseous state.
Gaseous state. Very good. So methane also, maximum methane contains what? Natural gas. Natural gas contains most probably methane gas. Will reacting with burning oxygen. If you start burning oxygen, balancing equation I'm writing, it will start producing CO2 plus. CO2 is a what? Gaseous state. Plus it will produce vapors. Understanding? Water means don't write here liquid. It will produce vapor water. Vapors. So that only I am writing the gaseous state. Plus it will produce heat energy. So this is also one of the example of heat releasing equation. Is it okay, da?
Yes, sir.
Yes, write it. These are the two examples. One more example also I will say. Most important example also I will say. Do it. Till here you finish it. Is it okay?
Yes, sir. Finished, sir.
Can I erase?
Yes, sir.
Yeah. So now see, if you'll observe more clearly, understand one more real life example which you have to study under this one. The most important question from the chapter, why the respiration is also called as exothermic reaction, they will ask. So if you'll observe here, the burning of, understand, the burning of carbon, the burning of natural gas contents like methane, ethane substances and all, they are also we can call as exothermic reactions because heat is producing. So as well as if it comes to know here, so if you want to survive, we need food, correct or not? We need energy to stay alive. Is it true or not?
Yes, sir.
Yes. So if we take that, for example, combustion of fuels like wood, coal, kerosene, petrol, diesel, all are example of burning of any substance is an example of exothermic reaction because every reaction heat is releasing or else reaction produces the heat energy. So if you take even the combustion of food like glucose, the substances which we are eating, understand, glucose in our body during respiration is also example of exothermic reaction. So why the respiration is known as exothermic reaction? Let us discuss now. So now, if you want to survive, as we know that if you want to stay alive, we have to eat the food. We need energy. So how we will get this energy? So we will get this energy from the food which we will eat. Now, after I am eating, what I will do, I will swallow it, everything will go to our digestive system. So in our digestive system, if you will observe, food is broken down into a simpler substances, smaller, because directly it cannot go for digestion. Now, so that is why, as we know that biology have studied, digestive system, it will make the food broken down into simpler substances. For example, if you eat the food like chapati, bread, rice, potatoes, everything, they are all complex substances. They contain mainly starch, carbohydrate. They are contains mainly starch and carbohydrates. They contain. So now these are very highly complex substances. So what will happen during the digestion? These starch carbohydrates is broken down into a simpler carbohydrates called as glucose. What we used to call instant energy.
Glucose.
That is why you can see if you become tired, they will say instant energy, you please drink the glucose. Is it correct or not? Because by the time if you eat the food and all, it will take time to digest and releasing energy by our body. That is why they will say us to take the glucose immediately, instant energy we used to get, because glucose is a very simplest form. So directly it will go under the digestion reaction and it will release the energy very immediate. So that is why this glucose then undergoes slow combustion. Combustion means inside our stomach, like compression, like our bike fuel. It will become combustion by combining with oxygen, which we are taking in inhaling, understanding. So these simpler substances will reacting with, understanding, oxygen, which we are breathing, respiration reaction, understanding, and they will start forming the combustion by combining with oxygen in the cells of our body. They will start producing energy. That energy, they are releasing energy, means in the sense of what we used to call, that process is called as what? This full process is called as respiration.
Exothermic reaction.
Yeah, respiration. So that it is energy is releasing, so that we can say that it is a exothermic reaction or endothermic reaction. Energy is releasing.
Exothermic
reaction. Understanding. That is the reason why the respiration is known as exothermic reaction. And why this heat energy is releasing in this one means, understanding. And if you observe here, in addition to other functions, this energy maintains our body heat. That is why this heat energy is releasing. So if you observe this respiration reaction, chemical reaction of this respiration, then as we know that, what is the formula of glucose? Any idea? Anyone? C6H12?
C6H12O6.
O6. Very good. So C6H12O6 is only called as glucose. What was to call? Glucose. Which will be
Glucose.
reacting with oxygen, which will reacting with oxygen. I am writing a balanced equation. You should learn the balanced equation. And see, oxygen, I am reacting with oxygen. Then it is used to form the energy 6CO2. Carbon dioxide gas is releases. That is only we are exhaling. Understand? Out. Carbon dioxide plus it will form 6H2O, liquid state of water, plus the main thing, it will release energy. What it will release? Energy. So what is the use of this energy? What is the use of this energy?
Photosynthesis.
No, this energy maintains our body heat. What are you talking? Photosynthesis is another thing. Understand?
Okay, sir.
This energy is releasing in our body, inside our body. It will maintain our other functions of our body. So this equation is only known as respiration reaction. Why the respiration is known as exothermic reaction means because heat is releasing in this. When the glucose reacting with the combustion reaction is taking place between the glucose and oxygen, they will produce carbon dioxide, understanding water and energy. That is why it is known as exothermic reaction. Is it okay? Clear?
Yes, sir.
Yes. Write it now. So that is the reason respiration is an exothermic process, because energy is produced during this process. Okay, write it. Respiration reaction. Heat is evolved or known as exothermic reaction. This is the third example, example 3. Why the respiration is called as exothermic reaction? Then you can write this. Understand? Is it okay, Amma?
Yes, sir.
Write it. Anusri, are you understood, Anusri?
Yes, sir.
Yes. So now, if you'll observe very carefully, understanding. So this is all about the examples of exothermic reaction. Also, you can see, starting of this lesson, we have studied burning of magnesium. Have you remembered? Burning of magnesium I have taught. Burning of magnesium means magnesium will start burning. What will happen, Amma? Magnesium is in a solid state. It will start burning the magnesium with oxygen. Oxygen from where? Gaseous state from where? From air. Understand? From air. Then it will start forming magnesium oxide. 2MgO. Balancing equation. 2MgO. Then this is also heat energy will release. So that is why this is also an example of what?
Exothermic.
Exothermic reaction. Understanding? This is also example of exothermic reaction. So this is all about the examples of exothermic reaction. Now we have one more type of reaction. What is that reaction? One more type of reaction. What is that? Heat changes. This is all heat changes. Endothermic reaction. So let us go for the next one. Endothermic reaction. This is the most important, and examples also most important. Now here heat evolved means in the sense of exothermic. Next, what is endothermic? Anybody, any idea? What is endothermic?
Heat is absorbed.
Heat absorbed. Very good. So those reactions in which heat is absorbed, understand? Endothermic means heat is absorbed. Means if the reaction wants to take place, it needs to provide the heat energy. That reaction is called as endothermic reaction. Heat absorbed is known as endothermic reaction. So let us go for example. Nitrogen and oxygen. If you want to form any kind of nitro and oxygen products, then I will take the nitrogen. What is the nitrogen? N2. Remember, nitrogen is also a polyatomic molecule. Nitrogen is a which state? Anybody? State you should say. I should not say. You have to make it learn now onwards. Nitrogen is what?
Gaseous.
As well as oxygen, which is reacting with oxygen, which is also what? Gaseous state. Understanding? So gaseous state. So if you want to form the compound called as, understand, nitrogen monoxide. So when the nitrogen and oxygen are heated to a very high temperature, means we have to represent here plus heat in reactant side. We are heating the reaction. Reactants. Are you people understanding? So that is why I am writing this side. Is it okay, Amma?
Yes, sir.
Plus heat in reactant side. Plus heat in reactant side. So it will form a compound called as nitrogen monoxide. Again, it is also in gas. So balancing by 2 here because these all are 2, 2. So I am keeping here 2. So to form the nitrogen monoxide, monoxide, understand? Monoxide. This is a example of endothermic reaction. Do you know what is the heat temperature we have to eat? Do you know what is the temperature? We have to eat, understanding, we have to heat 3000 degrees Celsius. Then only we used to get the nitrogen monoxide gas. Is it okay now?
Sir.
Yes or no?
Yes, sir.
Yes. So here, observe, in product side, if you mention the heat energy, it is exothermic reaction. If you write energy plus heat energy in reactant side, this also same thing, plus heat I can write, or plus heat energy I can write, or else simply I can write plus energy. Understanding? Anything. If I write in reactant side, it is an endothermic reaction. What is to call?
Endothermic.
Endothermic reaction. So let us go for next.
The amount of heat will be the same or different in every reaction, sir.
No, ma. What, ma?
Sir, the amount of heat will be, sir, here you have said that 3000 degrees Celsius now, sir. It will
What?
be same or different. Sir, the amount of heat will be same or different in every reaction.
It will be
sir.
different, amma. This for this reaction 3000. If you want to take some other reactions, some other value, it won't be constant. Understand?
Okay.
Depend upon the reactants, it will change. Understand? Okay?
Okay.
Is there no Ashika?
Yes, sir.
Yes. Now, for example, let me go for next reaction. It will take. Understand? For example, if you take the calcium carbonate, what is the state of calcium carbonate? Calcium carbonate. Calcium carbonate. Second example. CaCO3. Calcium carbonate. If you take calcium formula, you have to learn formulas. Calcium carbonate, if you take, actually it is present in solid state. So if you start heating, then understand it is used to form calcium oxide, CaO, solid state, plus it will produce carbon dioxide gas. Heat is absorbing here to form this. So calcium oxide, this is calcium oxide, solid state, and carbon dioxide will form. So this is, we can say that, understand what we can say, endo or exothermic reaction?
Endothermic reaction.
Endothermic reaction. As well as you see, digestion is an exothermic reaction. Photosynthesis, you tell me. Photosynthesis is a what? Photosynthesis reaction. Example 3. What is the photosynthesis reaction? 6CO2 plus 6H2O, which will give you light energy is absorbing. Light energy, sun is absorbing. That is why we can write above the